Hello everyone and welcome to today's episode of Advent of Code 2022 in Go. Let's start with the puzzle that we have today for day 3. Let's look at it. What is the problem that we actually need to solve? So we know in the past episodes we also had to deal with elves, and now it's obviously again something about the elves. So one elf has the important job of loading all the rucksacks with the supplies for a jungle journey. Unfortunately, that elves didn't quite follow the packing instruction, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of the given type are meant to go into exactly one of those 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item per rucksack. The elves made a list of all the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified as a single lowercase of uppercase or uppercase letter. That is a refer, okay. Lowercase a and uppercase a are different items. Makes sense so far? The list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represents items in the first compartment, while the second half of the characters represent items in the second compartment. Suppose now we have a list of different items. First rucksack contains the items, this one, okay. Which means its first compartment contains the items, I don't know, while the second compartment contains the items, these. The only item type that appears in both compartments is lowercase p. Okay, because we find it here and we find it there. Okay, makes sense so far. The same, there is L in this one, here and here. And then in third we have uppercase P. Oh, okay, yeah, which makes sense there and there. Okay, so I think this is something that we understand. So, and now help prioritize item rearrangement. Every item type can be converted to a priority. So A to Z have priorities 1 to 26 and A to Z uppercase have 27 to 52. Okay, so in the above example, the priority of the items appears in both compartments is 16. Okay, now it's about the items that are double. So, and for each of them, basically you build the sum of all those priorities of the items that are double. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? Okay, so basically we are giving those lists, and then in each of those lines we need to figure out which item, or in this case character, is included twice. And then for each of those lists we get a priority, and these for each of those lines, and then for each of those priorities we just sum them up and end up with a number that we need to get and answer here. Okay, sounds straightforward. Let's look at what is our input that we get and copy it into our new project that we have here. So copy it over, new file, rucksacks.txt. Okay, not that problematic. Maybe we also create a text file already for testing, which contains only the tests.txt, which contains only the example mentioned within the description. So if we go back here, we have this, and it might become handy to just run our code on the examples first and to see if we get the correct result in the end, and then run it basically on what we got as input. So copy that and then enter it here. Sounds good. And now let's start implementing what we actually have to do. So we start with a simple application. day 3 dot go. Good. So first we need to think about what are the things that we actually have to deal with. So we have individual lines that define a rucksack, let's say it that way, and each of those rucksacks has 2 compartments. So let's first define those as types, might become handy. So we have a rucksack, and that struct, and these rucksacks have 2 compartments, and within each compartment there are items. So say compartment items, let's say 1, which is of type slice of items. So since we don't know the number of those items, we need to use a slice, and then we have the same for the second compartment. So, but now we need to define, this doesn't look right, unresolved, yeah, of course we don't need this. So now we need to define what actually is an item. And for us, basically the item is just something that has a symbol, or since the individual items are represented by symbols when we read it from our list here. Okay, so far so good, not that complicated. So then let's start with it and try to read in the lists of all those different rucksacks, or go through them. Basically for that we first need to create our input file and use open, and then our file that we start with is basically this test.txt, which this should be fine. And then as usual check if we have an error. If we have an error, we need to handle it in any way, in some way. So therefore the easiest thing is just assume we are always doing the right thing, and if we have an error we just panic. Not that complicated so far. Good, then we need again to go over it and read it line by line, because basically the file, each individual line contains one single rucksack. So if we want to parse it, it makes sense to split it up into individual lines. This is why we used the scanner library before. Let's try out if we can scanner. How did it go? We created a new scanner. No, how did it work? Let's look again at the recent project from yesterday. I definitely need to keep track of that. Buff.io, not scanner. Okay. So we create our buffered.io scanner, and then for scanner in scan, is this correct? Yes, we just scan it, and then we get the individual lines from the scanner.text. And this should give us basically the individual lines. So to test if what we are doing is actually right, I forgot, we still need to close our input file at a later point, so defer the call. So what this means is basically that in the end, after everything has been run through, this input file close is being called automatically, so that we close the file and don't longer have any reserved resources that are no longer needed. So as a first test, we can just print out basically what we read from our line. So we just print line, and then basically what we should see when we try to run it should be just basically running the whole input, or basically printing the whole input that we have in our test file, and this looks good, I would say. So looks quite the same. So reading the file seems to work. Nice. So now the point is we need to split these lines into two different compartments, right? So at least this is what we understand here. So we take this line and split it up into the first part and the second part, and they are always contain the same number of items. Here, a given rucksack always has the same number of items in each of its two compartments. So this means the number of compartments of items is then basically the length of the line, but divided by 2. So now the problem is we might run into some issue when you, for example, have a line that contains a line length that is not a multiple of 2. So better to check for that. Otherwise we would end up with 2 different lines. So this is something that we can easily check if by just multiplying the length, the number of items that we have, multiply it by 2 again, and then see if this is equal len from line. So, but this might look, nonsensical, because basically we define number of items to be, the half. But the problem is that if this is, for example, 15, the result wouldn't be 7.5 for number of items. But since this is an integer, which means there are only whole numbers, so it's not, it doesn't support decimals. 15 would return 7, and then by 7.2 we would be 14, and this would be 15, and then we could easily detect this error. So therefore it doesn't hurt to basically check for that. So do some format.error invalid number of items. Invalid, it's basically different numbers of items in compartments. Okay, and then panic. So this is, it always makes sense to check the input and to see if this actually if what you expect is what you get. Otherwise you might run into some, what does it say? We already have an error. Okay, this doesn't look good. This shouldn't happen, but we will see. Let's debug into this. And we see our line is the first line. Number of items is 12, len of line. Add to watches 24. Okay. Okay. This is a typical mistake. Just getting the condition wrong. We checked if this was equal, but we need to check, and this is just if it's not equal is the error case, not the same, not the other way around. So restart, and now it should run through. Okay. Good, so this means we now have the number of items that we expect, and this allows us to split the line into those 2 different compartments. The first compartment, items 1, is basically this items is basically then the line from the beginning to number of items, and items 2 is line from number of items, so from the, let's say from the 10th till the end, if we have 20 items in total. So now we can split this into those two parts, and from them it would be nice to have a method that parses our items, or we can just keep it strings, but let's just create those items from it. So therefore we need a method to parse it and create those items and store those instead of the string. So let's write a new function for that. Function parse items, which is given item string and returns a slice of item. So this should be quite easy, right? Because we just go through the individual string. So for index item in range from item string, so we just loop over it, and then we first need to create our list. So basically have items, which is item, a slice of items. Okay, we don't need it this way, we can just do it this way. So our items, and then we just append to our items the new item items strings and item string. Okay, so this contains all the items, this is only the string representing one single item. So, and we create a new item out of it, where we say the symbol is basically the item string. Type int. Why is the item string an int? We can just do item string. I think this is because, let's see. Item string type uint as the type string. Okay, so basically this seems that Go doesn't return, uses a type int 32 for the symbol. Okay, and then basically we append to items, append items, our item. So an index is something that we don't need. And then we return our list of items. Okay. So, and now instead of just using this, we parse our items from those individual lines. Parse items. Okay. But this is not exactly what we need right now. So let's check back what is the requirements say. So basically we split it up into two parts. For each of those parts we create a list of these items, and then we need to check which items which items appears twice. So we need to compare those two lists of items or slices and find what is actually the same. So we go over those and identify the common items within it. So for that, let's check Golang. What we need is basically the intersection of slices because we need to find out which are actually the shared things. So we could do this optimized, but I think at the moment it's not important. Okay, it doesn't seem that there is one easy answer at the moment. So the easiest or the best way usually is to do this via some set. So we can create a set which is in Golang set. We don't have a set. Okay, this is unfortunate. Okay, but we can use a map for that. Okay. So let's try. Basically what we can do now is change the return type to be a set, a map of int 32 to bool. Or what are they using there? Bool, I think, yes, bool. So, and then basically we create here our map. 32. Bool. And then instead of appending, what we just do, we remove this item so we just put into the map items dot. This is append. Now how does this work with we just assign it. Okay, this makes sense. We just use the value and assign true. Okay. Okay, so basically we just use items and then use as an index the item value, which is this one, and just assign it true. So, and then we have our items 1, items 2, and then we can try to find the shared one. So we just loop over items 1, in items 1, range items 1, and check if this value, if any of those values that we loop over can be found within items 2. If items 2 value, so this would be only then true if, why is this bool? So basically we loop over the individual values and then every value that is included there, or every key. So, and then basically we check if this is also within items 2. And this should allow us they do it a little bit different. So basically they check and then it returns the second value and it sounds okay. There's also the code for the intersection. Yeah, okay, but this is basically the same. Okay, so it works works in the same way as we do it. So if it's inside, then we found our shared element. So we just print out format, print line, found shared item, or item in both compartments, item. Let's print it out in both compartments. Print f, since we are formatting this, add a new line, and then print out value. So now if we run this, we will see what comes out of it. Okay, assignment to entry in nil map. This doesn't look right. Okay, yeah, we are probably not creating the map in the correct way. Yeah, we just define it, but it's not there. So var items make map. Okay, but this doesn't look correct, right? Because we would like to have there not just an integer value, but we should have the character that is in both places. So for example, P and P here. So we need to convert back from this integer value to a character. Okay, let's check how we do this. So within Golang convert int character. Convert into ASCII. Okay, ASCII is room. No. Fonts print string. We just converted. Sounds too easy. Use rune instead of int. String rune. Okay, run it on the playground. For any rune value, not just ASCII subset. Okay. Let's try it out. And say value. We convert it here. And we see, this looks way better. Okay, nice one. So we find the common value. So if we don't find any common value, I think we should end with an error as well. So therefore we can keep track basically of if we found something or not. Found equals false. So we initialize our variable, and then if we found it, we set it to true. And if we didn't find it, if not found, we return an error, because this tells us that the input is not correct. No common item in both. Should not be capitalized or end with a punctuation mark. Okay, if you don't want the punctuation at the end. Okay, still works. So we always find something. Looks good. Good. So now going back to the problem at stake. We now have our common items. This is here the P, the L, large P, uppercase P, E, T, S. Check back with those. yeah, this is basically what we expect, is what we got from the example. So we can be quite sure that what we are doing so far is not completely wrong. So now we come to the priority. How do we convert between the letters that we have and our priorities? So, and this is basically where this encoding comes in. So depending on the encoding, these individual characters have different numbers. So for the encoding that we are using at the moment, this is basically this ASCII, where we can check the priority. So let's look at the ASCII table. And the ASCII table gives us the number of each individual character. So for English characters, let's say it that way. So for us, for example, we know that the capital A is 65, small a is 97. So if we now want to convert between those numbers that we have in there in our value and the individual priorities that we have here, we need to understand, or we can just map it from the value. So therefore we can create a new method which basically does this mapping for us. So let's create a new method which we can call get priority. Then this takes a single integer value and returns another int, since the priority is also a integer number. So, and then we can check based on the ASCII numbers that we have where we are. So if, for example, we know that the value is larger equals than, well, let's look back in our ASCII table. If it's larger equals than 97, then we have all those small characters till 122. So everything which is in between, we can just map there and say, okay, we map the A to priority 1, which means we take the value and just subtract 96, and then we should be safe, right? So we can always subtract 96, and then we get directly the priority that we should get. So for A we get 1, for Z small z we get 26. Let's check this, if this works. So if value equal or greater equal than 97, and we also need to check that we are with smaller than 122 and value smaller equal than 122, then return value subtracted 96. Not that complicated. Let's just return in 32 as well. So other cases. So we have also large numbers, right? And if we look at the ASCII table again, then we find the capital characters from 65 to 90. So we do basically the same, just with different numbers. So going back, is if value 65 to 90. Was it 90? Let's check again. 65, 90. Okay. Looks good. So then we subtract not 96, but we subtract 64. Oh no, not 64, because we return different priorities. The starting priority should be 27. Okay. So therefore 65 to 27, this means we subtract 38. Let's see if this makes sense or is correct. So for every else, we all can again just panic, because we shouldn't run into other numbers. Error function invalid item value. Okay, and now we calculate the maybe we should also keep the value, right? We should also common item just make it 0. So we assign our common item equals value. Okay. In 32. So, and then we get the priority of it. Priority is equal get priority of common item. So then we just print it out. Priority of item is, and then priority, and this is common item of common item. Okay, let's run it and see what happens. Nothing. This doesn't look right. Okay, so seems we are. Okay, now it worked. Found item P and priority is 16. Of L is 38, 42, 22, 20, 19. Okay, let's check basically with what we have in our puzzle. 16, 38, 42, 22, 20, and 19. So the sum is 157. Okay, sounds not too bad. So trying to do the same. And now we need to sum those priorities up into one single thing. Total priority so total priority, and we just sum it up at the priority, and in the end print out the total priority. Priority is total priority. Okay, run it. Total priority 157. And 157 is exactly what we should get out of this. So we can be quite sure that what we did so far is not wrong. So trying. Now let's run it not on our small tests that we have, but on the input that we got, which is basically our rucksacks.txt. Run it. And in the end, we get a total priority of 7,674. Okay, copy it and submit it. And wow, okay, this is correct. Nice. So continue to part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have the item type B somewhere in their rucksack. And at most, 2 of the elves will be carrying any other item type. 2 of the elves will be carrying any other item type. Okay, this I don't get. Let's read it again. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. Okay, so far so clear. And at most, 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year updated authenticity stickers on. So I don't get that completely. At most, 2 of the elves will be carrying any other item type. So this means that they only contain 1 item? No, this doesn't make sense. The problem is that someone forgot to put this year updated authenticity stickers on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have different badge item type. So in the above example, the first group's rucksacks are the first 3 lines. Okay, and the second are the next 3 lines. Okay. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. This one, this one, this must be their badges. In the second group, their badge item type. Okay, so basically the only word that is, not the only word, the only character that can be found in each of those 3 lines is the R. Okay. In the second, it's another one. Their badge type must be Z. Priorities for these items must still be found to organize the sticker attachment efforts. Here they are 18 for the first group and 52 for the second group. The sum of these is 70. Okay, so the priority is the same. I'll keep find the item type that corresponds to the badges of each 3 elf group. What is the sum of the priorities of those item types? Okay, so basically we can assume that each group comes directly after each other. So basically we only after each 3 lines we have to check if those what are the common items within those lines, and then we have this badge type, and then basically calculate the priorities of those. Okay, so let's do this. So this means basically we need to pass our items multiple times. So we need to keep the items across different lines. So we have one new variable which contains our common items within group, which starts basically with an empty map. Where do we have it? Map in 32 to wood. So, and then we, depending on which, we also should count which elf we have in the current group. Or current elf in group, and this starts with the first one, right? So, and then basically we check if we have the first in the elf, then basically what the common item within them. Let's check again. Every set of 3 lines correspond to a single group, but each group can have a different badge item type. First group. So we need to keep all. We initialize this with that. So how do we merge them? We would need to merge these individual maps. So if elf, let's do it at the end. If elf, current elf in group. So if it's the first, elf, right? Man. If it's the first elf, then basically we just need to make sure we initialize our common items within groups and make sure they contain all the items from this first elf. So we say this is equal to items 1, and then for item in items 2, not in, these are things that I probably don't get used to that much. We also set them within common items within group. Item equals true. So basically what this means, we initialize this common items within group with to be the same. Or can we just copy it? Is there some copy operation? So we don't change it. Copy, no, this is for something else. Copy map. Okay, let's ask Google. Oh, okay, I was completely in the wrong one. So basically, this is what we do. We have this common items within group, which is just a map from int to bool, and then we initialize this with the items that we found in the first part, and then append additional items that we get in the second part, but we only do this if this is the first elf of the group, right? So, but for that we don't want to modify it. Oh, but we can modify it. We don't care anymore afterwards, so we can just reuse it. So therefore this is fine. So now if it's the second elf in the group, then we basically just update and remove every item, or just make sure that we end up with the items that are shared between both. So we loop over the items here for in common items. Item in range common items within group. We check if this is actually within our items. So if items 1 items 1 item or items 2 item. So this basically checks if the item that we found in the first elf is this something that we can find within the second elf. If it's something within it, then we can just keep on. If it's not in there, so we need to change it. If it's not in there or in there, this means basically we know that it's not common between within this group, right? Because otherwise we would find it in one of those compartments. So we just remove it. So we can do, I don't know if this actually works, but we will see. Delete item. Hopefully this works. So and then this is what we do for else 2, and we do this also for else 3, I think. Else if current elf in group equals 3, we must do the same thing. But then in addition, we also check that we print this out, or that we find the only items that are in there. Because in the end we should only have one item left that is common. If len bigger than 1, so let's check if this is actually the case. And then panic that we have more items that are shared within the single group, which should not be the case. Panic. Multiple items within the same group. And then maybe also print those items. I'm not sure if this works, we will see. Okay, otherwise, if it's just 1, this is basically the case that we expect, that it's equal 1, then as if, then we just print out found common item format.printf found common item in group, and this is then common items within group dot. How can we get the first one within a map? This is something that I don't know, so let's go back to the browser and say get first of map. Can we just, if we know the key? No, we don't know the key. Use for range loop and break after first iteration. Okay, this sounds a little bit too easy. Okay, but it seems that this is okay. Fair enough. Let's do it that way. For value in range of common items within group. Value common item in group. Okay, so let's run and see what we print out. We don't see it at all. Makes sense because, okay, first we are testing on the wrong data. So let's go back to our tests, which is easier to look into. And here, the problem is that we are not increasing the current elf in group. So after we are done with the common elf, we just need to current elf in group plus 1 plus equals 1. And if current elf in group equals 4, then we set it to 1 because we only have the first, the second, and the third. We don't have a fourth. This is something we could do also easily with using modulo, but okay, let's see. It doesn't still work anyhow. So found item P in both compartments, priority of common item is P. Okay, so if something doesn't work like expected, let's debug in and see what we are doing wrong. So we know we are now at the first line. So we are now here. We expect that this is our first elf. This is correct. We get the items. Okay, and then let's look at the common items within group, which is okay, which is somewhat empty, it seems. Ah, yes, okay, makes sense. We are not that clever because we find it here. But this common item within group is something that we common items within group, something that we overrode, and this is not correct. So let's try again. We loop over it, initialize it, and now look at it. Okay, this looks more like it. So we have the individual items in there. Okay, go to the next and go to elf number 2 in the same group. We loop over it and everything which is not defined will be deleted. Okay, this is a large group. Whoa. Okay, but we see there's something off, right? We see that this is always looping over the same item. This might be due to some deletions, I don't know. Let's look at what is now common. It should be way less. Yeah, it is way less. Okay, let's see what happens when we go to elf number 3. Let's continue until we are here. Now it's elf number 3. We do the same stuff here again. And we see what is now left is only one single item, which is 114, which is correct, or at least what we expect. And the common item in item group is, okay, remove the breakpoint. I think we know now what found common item was R in the first group. Found common item would be Z. Okay, let's check it with the what we here found. Okay, they are 18 R and they are Z. Okay, let's print out their priorities. So calculate the priority. Priority is equal get priority from common item in group, and then total group priority we need to sum it all. Group priority. Oh, we need to do this where else? Outside. So, oh, we have the total priority and total
group priority. And we say group priority is this. We say total group priority is plus equals group priority. Found common item in group with priority. Okay, and then in the end, total priority is this, total group priority is something else. Okay, so run it. Okay, we should fix this error with priority 52. There's the new line is missing. We want to break the line break. Okay, so total priority is 157, total group priority is 70. Okay, sum of the group priority is 70. So if we look here, this is 70, what we expect for our test cases here. So I think we can be confident again that what we implemented is basically what we wanted. So try to run it on our actual data that we should test on the rucksacks. Run it. And we end up with the total group priority of 2805. Man. So, and let's check it. 2805. Submit. Okay, right again. Okay, this means basically we have solved this puzzle as well. Part 1 and part 2 looks good so far. 6 out of 6. I think we can be really happy about this. So then let's see if we can continue the streak tomorrow. So goodbye everyone and see us tomorrow.